Greetings. Welcome to our 21st episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
And hello, everyone. My name is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we are going to focus on geosynthetics and mining. Our guest today is Denys Parra, who is the general manager of Andes Inc. in Lima, Peru, and he is also an associate professor of civil engineering at the National University of Engineering in Lima. Denys, thanks for squeezing this podcast into your busy schedule and joining us from Lima, Peru. We received a number of questions during and after your webinar about mining, geosynthetics and mining, and I would like to ask them to you. So our first question is, are PVC geomembranes recommended for mining applications? If so, what applications?
Currently, PVC geomembrane is used in some specific cases. The first one, for example, is the use as an interleaf liner application in copper heap leaching in Chile, where an easy and quick installation is needed. The other case is in lithium industry, where large areas of PVC geomembrane is used mainly in Chile, in the Atacama Desert. This is the two cases of PVC application in mining.
Great, thanks. Denys, next question is, also for heap leach pads, would there be a situation where you would prefer using a double composite liner system instead of a single composite?
Yes, we have a specific case where we have the concept of a pad in pond. This means that the leach solution needs to be stored in the same leach pad area by creating an impoundment area with a dam. This means that the solution needs to be stored inside the leach pad. In this case, where we have a very high hydraulic head, we need to place a double liner system in the whole impounded area up to the top of the dam. And also this double geomembrane system need to have a leak detection in the middle of the two geomembranes. It's the same concept as we use for a PLS pond.
Okay, thanks, Denys. What design methodology or bibliography do you recommend for heap leach pad design using geosynthetics?
The base reference is, of course, the designing with geosynthetics of Professor Robert Corner. However, also we recommend several technical papers dealing with these topics. Most of them has been published in the Heap Leach Solution Conference series from 2013 to 2016. The next Heap Leach Solution Conference will be in Reno next year, 2021.
Great, thanks, Denys. Next question, what are the challenges with installing geomembranes and geotextiles at high altitudes, winds, and low temperatures?
In high altitude, there is not a specific technical challenge, but we can see reduction of the staff and equipment performances for installation. It's very hard to work, even to think in these very high altitude conditions, like we have in the Andes of South America. In the case of the wind, we need a quick installation of temporary anchor for avoided accidents. And in the case of low temperature, we need to weld the geomembrane during the warmer part of the day by using a flamethrower to create a small environment with adequate temperature.
What are the concerns of downslope bentonite migration on the steep slopes that you showed? Are GCLs being placed on the rocky surfaces that were visible in your photographs during your webinar? If so, what are your recommendations for protecting the GCL against damage? For example, do you use multiple layers of GCL when there's a rough subgrade?
Yeah, the migration of the bentonite on a steep slope is a concern. And for that reason, we need to use needle punch GCL to avoid that risk. And that works very good. At least the experience indicated that works very good. In the case of rocky surfaces, the GCL and then, of course, the geomembrane need to be protected. And as we show in the presentation and in experience in this kind of aggressive slope, we can use electro-welded mesh. Also, heavy geotextile have been used a lot in this also application. Geocomposite also is the preferred option because also we can use that as a drainage. And also we can use mortar, also soil cement. All those methods can be used for protection of the GCL in these rocky surfaces.
Okay. Next question is, what kind of geomembrane do you recommend for exposed applications? HDPE, when exposed for an extended period of time, would not perform well.
In fact, currently we use HDPE or LLDPE, and currently the LLDPE geomembrane is manufactured with additives which increase the UV resistance. We had a case in the Andes of Argentina, over 4,000 meters, that we took a sample of LLDPE geomembrane exposed during 10 years, and we did some testing on that sample, and that indicated just minor reduction of the properties. So there's not a problem for having this kind of geomembrane exposed.
Denys, if you were to place the soil liner on a 1.5 to 1 slope, how do you compact the soil before placing the GCL?
Usually the subgrade compaction before placing the GCL is not needed. Even in the case of a not so compact soil. However, if we need to compact, because I mean, we need maybe to place a fill, so it's hard to do. In South America, we had experience to do a compaction in a very steep slope by using a roller which is pulled by a winch system. So we cannot work with a roll in the slope without that kind of consideration by safety restrictions.
Thanks, Denys. Next question is a shear strength question. Would there be a strength loss, or maybe an additional strength loss, in a needle punch GCL beyond the residual strength due to high strains or displacements from a seismic event? In other words, so I'll just leave it there. So additional strength loss below the residual strength.
Because of a seismic event, you said?
Yes, seismic-induced deformations.
Of course, during a seismic event, we can expect seismic deformation, and that's a concern, of course. But for that reason, we have to install the GCL in the areas where this deformation will not compromise the seismic stability of the leach pad. Because, of course, we will have additional strength reduction. For that reason, we have to do our maximum effort to install soil liner in the area of stability zone. And that means close to the top, and just place the GCL in the areas which the stability is not compromised.
Okay. Next question. When opting to use a textured LLDPE geomembrane, is there a common asperity height or stud height or spike height used in the design, or does it come down to specific shear performance?
This spike, of course, the spike helps a lot. But testing that has been done in this kind of geomembrane indicate that the asperity height, I mean the spike height, is not enough. we need to deal with asperity density. And in this case, the area of that, that part of the geodesic membrane need to have additional asperity density. That is the way as we can increase the shear strength of the interface with the geomembrane and soil, and not only trusting in the height of those spikes.
Denys, another question we received is, do you use anchor trenches on any perimeter berms?
Yes. In the anchor trenches is needed. It's typical design construction. However, we can see that Thiel and et al. In 2014 recommended to place a geotextile to avoid, in that area of the anchor trenches, to avoid rupture of the geomembrane because of the waste drag down. In this case, Thiel study effects in landfill, but in the case of heap leach pad, the same effects can happen with the ore. So we need to protect that area of the anchor trenches in order to avoid rupture during basically the operation of the heap leach pad, or even during a seismic event.
Thanks, Denys. Can you discuss the life expectancy of a liner system in an acid mining system? And in addition, what are the main causes of failure after installation in an acid mining system?
In acid, the liner system, in fact, is not affected by the acid leaching, copper heap leaching. At least we don't have that experience. The problem here is the temperature that can reach up to 50 degrees Celsius, which can reduce the geomembrane properties. Then the temperature need to be monitored. However, we didn't see problems that have been reported because of this issue.
Okay, last question. I understand that protection on sharp rock slopes is, from your webinar, you had photographs of chain link fence, soil cement, and you mentioned that just a minute ago, or gunite. Please confirm this, or are there other methods of liner protection against sharp rock slopes?
Right. As I said before, in our experience, we have used also electro-welded mesh, heavy geotextile, and geocomposite. That's the way that we usually deal with protection of the geotextile in these sharp rock slopes.
And Denys, just a follow-up there, do you have a typical weight of the geotextile, say 16 ounces or so per square? What's your typical thickness or weight?
We can install up to, 400 or even 1,000 grams per square meter. That depends on how aggressive is the rocky surfaces. But in some cases we have to use a very, very heavy geotextile.
Right. Okay, that's all the time we have today. So Denys, thanks so much for your excellent webinar and this podcast, and joining us from Lima, Peru. If you have any other questions or would like additional information, please email me or Denys, and his contact information is at the end of the slides from the webinar, or you can visit the FGI website. So Denys, thanks so much.
Thank you, Tim. Thank you, Jen.
Okay, bye for now.
Bye. Thank you.